What's up, everyone? I wanted to make a video on variables for the Godot community to kind of teach about variables in a wider scope than just the Godot engine and give people kind of a background that will help them if they end up moving to other engines or if they want to do coding projects that aren't just limited to Godot. So, who is this video for? This video is for programming noobs and Godot noobs alike, self-taught people who may have gaps in their learning, which is a lot of the Godot community because we're all pretty much self-taught. So buckle up, this might be a long video. So, what is a variable? Literally, a variable is a container for data that we use as programmers. But figuratively, how we can think of a variable is a box. A box that stores information, and kind of one half of programming if you think of functions as the other half of programming. So, the origin of variables. Along with storing data, variables also determine the size of that data being stored. So for example, originally in C, which is like the earliest programming languages, one of the earliest programming languages, a character was 1 byte, an integer was 2 bytes, a float was 4 bytes, and a double was 8 bytes. So in this way, a variable not only determined the kind of data being stored inside, but it also determined the size of that data as well. So that led to some interesting problems in early programs. You might have heard the term integer overflow. An integer overflow would occur when there was too much data for the container. So for example, 2 bytes is 8 bits in binary, and it can only go up to the number 255 in decimal, so you can store the numbers between 0 and 255. This is why numbers like 255 and 256 are usually significant in old programs. Many old programs have bugs relating to variables exceeding these numbers. This bug is referred to as integer overflow, for the above reason. Values become too large for its container, causing unpredicted or unwanted behavior. So if your container only went up to 255 and you went up to 256 by accident, you're going to start messing around with memory around where that memory is stored, which is not what you want to do. In modern C, though, an int can be 2 or 4 bytes, so it can store much larger amounts of data if it's 4 bytes. So let's do some quick vocabulary real quick. A variable declaration is when we first name our variable within the engine. So in Godot, this is done with the var keyword. So in this example up here, I have var, my var laid out. A variable assignment is when we assign a variable to a variable we've declared. So right here, my variable equals 1, or my var equals 1, assigns the number 1 to my var, and thus it's a variable assignment. These are typically done in one smooth statement like this, and sometimes they include the data type as well. So var, my var int, you can see the data type right there, and it equals 1. So it has the variable declaration, the variable assignment, and the variable data type all in one neat line of code. So, moving on. After we developed variables, we developed objects. Over time, new programming languages were developed that allowed us to store far more dynamic data inside of variables. These new languages allowed us to attach functions and properties to variables, making them much more flexible. This concept of attaching functions and properties to variables, hard for me tonight, became known as object-oriented programming. So, is an object a variable? Kind of. An object is a collection of variables and functions. However, in code, we often treat them exactly the same. We declare them, we assign them values, we modify them. So, GDScript, for example, is an object-oriented programming language. When programming inside of GDScript, we oftentimes create new objects for everything from characters to raycasts to hitboxes to simple rectangles. You've probably created an object and you've certainly used them. You just might not be aware of it. The car analogy. A car is a great way of thinking about objects in object-oriented programming. Cars have properties such as their color, their top speed, their make and model. Cars also have functions like start, stop, brake, and accelerate. And you don't need to know how all of these functions work or how they're made to drive a car, but by clever design, you are able to use them without that understanding. That's called abstraction. So, let's take a look at a variable declaration in depth. We're going to break down each of these colored segments and we're going to talk about what they do and what they mean. So first of all, let's talk about that little bit in yellow, on ready. On ready is an annotation, though they commonly refer to them as a tag, and especially in other languages, they'll call them a tag. These change how variables are treated by Godot and provide a variety of functionality. Next up, we have the variable keyword, which is needed when creating a new variable. For the first time, anytime you make a variable, you got to use that word. Then we have the variable name, which in this example is my object. It's an arbitrary name that we use as programmers to distinguish our variables and objects and tell them apart. Next up, we have the variable type, or in this case, the object type. And this object is of the type object, which is available in Godot. And this is the box that we talked about at the beginning that our variable or object will reside in. It determines how we can use our variable / object. And lastly, we have the assignment. In this case, we assign our variable to a new object, object.new, and this gives the variable its value. So, let's look at the export tag really quick. If you've been in Godot for any amount of time, you've probably seen this and you might wonder what it does. You might already know what it does, but if you want to modify an object or variable directly from the editor instead of in a script, we use the export tag along with an explicit variable declaration. As you can see here, we have the export tag and then our variable declaration along with its type. You can still set a default value, and it's wise to do so. Our character now has a health property that we can access from directly in the editor. We can also use the export tag to reference objects inside the editor as well, allowing us to assign object references without using any code whatsoever. We just simply do the export tag, the object type, and then when we go into Godot, we click the assign button, and we can filter through our nodes to find the correct object. So in this case, I used a collision shape, and when I click the assign button, the only collision shape that I actually had active in the scene was the one attached to the character node 3D, and so that was the only object that came up. So, explicit versus implicit variable declaration. There are two ways we can declare our variables within Godot: explicitly or implicitly. When we declare implicitly, we let the engine infer what the variable type should be by looking at the data contained inside the variable. So if we used var player and then didn't assign anything at the start and didn't give it a variable type at the start, but then later we assigned a character body 3D to it, that variable would then become of the type character body 3D. That is implicit variable declaration. The alternative, and what I think is much better, is explicit variable declaration. We tell the engine ahead of time what our data type is going to be. So in this example, I actually have the data type along with the variable declaration. That's the big difference, is in the variable declaration, I have the data type right here. That's the difference between explicit and implicit. Implicit, no variable type. Explicit, variable type. So, we can do implicit variable declaration if we're lazy. var my object is a completely valid variable declaration. Totally fine. The variable does not have an initial value, so attempting to use it can produce errors. You have to make sure you have a value in it before you try to use it. As well, the object doesn't have a type, so the editor won't be able to assist you with IntelliSense. When an object is declared without a type, it is said to be implicit. So let's take a look here at the benefits of explicit variable declaration. It promotes proper coding. It's slightly faster because the compiler can read it faster, and it's easy to use with the dot operator. The benefits of implicit variable declaration are it's quicker to code and to prototype. You don't know what data type you're going to need. It's easier to just forget about it. And data types can be changed arbitrarily, which is a double-edged sword. If you need to do that and that's what you mean to do, then that's fine, but it's most likely a drawback. So, to access the functions and the properties of an object, we use what's called the dot operator. The dot operator looks like a simple punctuation mark because it is just a period. However, its significance in object-oriented programming cannot be overstated. If you use the dot operator inside of GDScript, something interesting happens. You get this big old list of stuff we can do with our variable / object. The IDE populates an entire list of functions and properties from that object. So, because I've created a character body 2D object, I have access to the function apply floor snap, as well as the properties floor max angle and floor snap length. Not really important what those do for this video, but you can clearly see I have access to those functions. Functions are denoted with a .f parentheses symbol. So that kind of, if you know what functions are and you know how to use them, kind of looks like a little function at the end of the, at the beginning of functions. Properties are denoted by a .p, a capital P. And you can see the difference here. So these are going to be properties and these are going to be functions. Functions you need to use like functions. Properties can be used by like properties, like variables or arguments, like variables or objects. So remember, properties are basically variables. So by accessing a property, we either want to read the value stored there in that property, or we want to change that value stored in that property. So for example, we can type player.floor snap length equals 1, and we would set the property of floor snap length within our player object to the value of 1. Functions are different. They will do something and possibly return something, and also possibly need something. So for example, by typing player apply floor snap, you'll snap the character to floor. So let's talk about getters and setters really quick, because you might see them, you might wonder what they do. However, it's kind of beyond the scope of the video. The basic concept is, instead of accessing a property directly, we oftentimes want to access some code that instead will change that property for us or get that property for us. So for example, if a player takes damage, you could simply write player.health equals player.health minus damage. So that would be without a setter. There's a couple problems with that. If the player's health drops below 0, if you have UI elements attached to the health bar that need updated every time the health changes, there's a lot of different problems. So it's much better to use a setter function for health, because then those edge cases can be can be covered with inside the set function. So a setter function is called like any other object function, player.setHealth, health minus damage, and can contain its own logic and code. Like I said, this is a brief and bad explanation of what this is. It's just so you understand that if you see something like set object this, get object that, it is probably A, the better way of doing it than directly accessing the property, and B, it is also going to have code that you don't see running in the background potentially that actually accesses that property for you. You are not directly accessing it. So, object-oriented programming provides a lot of upsides. We have abstraction, which is, in the car example, we don't need to know how the gas pedal works in order to use that. That is abstraction. You don't need to know everything about an object to be able to use it. We also have clarity due to object-oriented programming. Objects are a nice representation of how people think of things in real life. A character body 2D makes sense to us. It makes more sense than a giant chunk of variables and objects just thrown out willy-nilly that we have to decode. Reusability. We can take objects and use them throughout our code over and over again. We can even oftentimes take them and use them across different platforms over and over again, or different projects. There's extendability. Objects can be extended to make child objects, which I cover in my parents, children, and inheritance video, but basically child objects are like if you have a truck, you might want a Toyota truck, and a Toyota would be child of truck because a truck is the brand umbrella on which a Toyota truck would be under. A Toyota truck would have all the same qualities of truck, but would be more specific. So, and also a benefit of object-oriented programming is modularity. You can easily take one well-made object from a project and copy it to a completely and different separate project, kind of like reusability. For example, the character body 2D object, which everyone uses in Godot, we can have access to across any project we use in Godot. So you can also create Godot modules to use across projects. You can publish them. A whole bunch of uses of object-oriented programming. The downsides of object-oriented programming are extremely limited, but it does use more resources, and oftentimes we misuse objects due to not understanding them fully. But these are worthwhile trade-offs in the long term for object-oriented programming. All right, break, shameless plug, get some food and get some water. Check out my links below for my Patreon. Buy me a coffee if you want to. They don't have anything on them now, but hopefully in the future I can put some stuff on there, like the maybe the resources that I use for these videos or stuff like that. Let me know what you'd want to see, my lesson plans, slides, projects I do, whatever. But also subscribe, like, comment, all those things. I know it's really cliche, everyone says it, but like I have 2 videos. This is my second video, please help. So, sorry for the jump cut. I took a break too. So let's look at making a custom class / making a custom object. To make your own class or object, as we've been calling them within Godot, simply put the keyword class name at the top of your script. So in this example, I have class name player to create my own custom player object. Once you've done this and you've saved your script, you'll see your object appear inside of Godot, even inside of other scripts. Note that now we declare an object to be of the type player instead of the typical character body 3D class. This is how we access our own custom extended object methods. Alright, null is a word that you might encounter when using variables and can be kind of scary at first. Null indicates a lack of value inside of a variable, and you will get errors if you try to use a null value. No values can occur for several reasons, but they can all be boiled down to a simple statement. A variable you are trying to access hasn't been assigned a value, or maybe it did have a value at one point and it does not have one now. While seemingly simple, complex interlocking code can lead to very hard to track down null errors. Godot's debug tools makes it much easier to track down these bugs, but they are only as powerful as you make them. So, quick tangent, null is not 0. You may think that null, false, and 0 are all the same thing in programming because they all feel similar. It's quite the common misconception. So, let's think about this. Having no money in your bank account is much different than never having opened a bank account in the first place. Both of these things are different than having a bank account at one point and closing it out. So in this example, having no money is 0. You have no money in your account. Never opening an account is null. If you went to the bank, told them their name, they'd have nothing for you if you told them your name. And then closing an account would be false. You'd go to the bank, you'd say, I'm so and so, and they would say, oh, you used to have an account with us, you don't anymore. So, all three of these things are very different in the real world. They're very different in programming as well. So, why does this matter? You may think that all of this doesn't matter in Godot. After all, in Godot, we don't need to declare our variables if we don't want to. We don't need to worry about manual memory management, all those crazy things in other programming languages. Don't need to worry about garbage collection. We don't even hardly need to worry about type errors, which are a huge issue in other languages. And objects are so incredibly easy to work with. So why does any of this matter? There's quite the benefit of knowing what you're doing. There's a lot of benefits to knowledge. Godot is an open source engine written in C++. So, GDScript isn't the only language supported by Godot. You can write scripts for your game in C, C++, and C# as well. All three of which offer faster performance than Godot. Faster performance than GDScript. That doesn't mean you have to port all of your code to a C-based programming language, but one day you may find that a C-based programming language is more well-suited for your needs. For example, say you wanted to produce a procedural generation script. You have a whole bunch of terrain, you want it to be different every single time you load up the game. That would be a good use of C, C++, or C#. Or if you want to make netcode, pretty much got to go with a C-based language if you want to make really good netcode. Yeah, C-based languages are the solution to both of those problems. By learning proper programming principles and having a deeper knowledge of the basics, you'll be able to quickly pick up other programming languages. So if you come to these tasks and you need to do C, C++, or C#, and you know all these concepts, it's going to be really easy to look at these languages and say, hey, that's a variable declaration. Or if you don't know how to do something, you'll know the verbiage, the wording behind it, so that you can look it up. So, another reason why it matters is bugs. The ultimate defense against buggy code is twofold: understanding your code and writing robust code. By not taking the path of least resistance and actually forcing yourself to write better code that you fully understand, debugging becomes less magical and a lot more methodical. Understanding data flow, data types, object-oriented programming concepts, all of these things are critical in this path of understanding. So, bugs continued. In a more practical sense, using object-oriented programming prevents sprawling and buggy programs by allowing programmers to break down code into modules, isolating potential issues. So if you have an object and you reuse it a ton of different times, you're not going to end up, rewriting that object so many different ways and bugging it out because you have 30 different versions of something that should really just be somewhere one time. If there's a bug within an object, you only need to fix the code in one place where you wrote that object. Once you've written bug-free code, you can reuse that object as many times as you'd like inside of your program. If your code is written really, really well, you could even transfer it to other programs or projects, or in our case, other games. So, quick summary: how to get the most out of our variables and objects. We should follow Godot's naming conventions and use descriptive variable names to be predictable and to basically take the guesswork out of variable naming. Explicitly declare your variables as often as possible. Understand the flow of your data. Use the class name keyword to create an object that can be seen inside of Godot's IDE. Use the dot operator to see an object's properties and methods. And when writing code that needs to be efficient, use the smallest data types possible. Also consider using other programming languages that are supported by Godot if it needs to be really, really efficient. So, let's take a look inside of Godot for some quick little demonstrations of what we talked about here. Alright, so let's look at the editor real quick. Let's talk about some things we talked about in the PowerPoint. So, I have opened a script on a character body 3D, right click, attach script, and it opens this, extends character body 3D. All fun and good. So let's declare a variable real quick. We will call it health. And we won't do anything with it. And this would be called an implicit variable declaration. And if we did like this, that would be explicit because now we have a variable type with it. So if we save this and we go to our node 3D, nothing changed. It's all the same basic stuff that's always in a character body 3D. So if we want to access health inside of the editor, we use the export tag that we learned about. So now over here, boom, you saw it pop up. We have health over here. We can even see it do it again because Godot is awesome. We delete export, it's gone. Put it back in, boom, it's there. Another fun thing we can do is we can set a default value. We can make our health 100 by default. So right here, we can still change it, we can still edit it, but if we hit the back arrow, health will go back to 100. So what about a different type of object? Or let's do an object because, you know, an integer is technically a variable. So let's do an object instead. We'll do the same thing and we'll do it with the collision shape. So we'll export var. We know we need the export tag to use it inside of the editor. We know we need the var keyword anytime we assign a variable. We'll just call this collision shape, and it will be of the type collision shape 3D. So obviously we do not have a value assigned to collision shape because it is all the way over there. It's hard to reach. So what we can do now that we've explicitly declared the collision shape and the export tag, remember we need to explicitly declare it because if we don't do that, editor gives us an error. Not use export animation or annotation without the variable initializer. Variable initializer makes it explicit. So we will go back, add that back in. And now we have collision shape over here. We can assign the collision shape within the editor, which makes life nice and easy. So let's change this up a little bit. Let's do var collision shape. Do it like a lazy person. Now we will do func ready. Oh, semicolon, colon. And we will do collision shape. We'll do our dot operator. And nothing happens because we haven't explicitly declared our variable. Godot doesn't know what a collision shape is yet. It doesn't know what it can do with a collision shape. So let's go back and we won't use the export tag yet, but we'll do collision shape. Now, when we go back to collision shape and dot operator, we have all these functions and properties that we can access. Let's see here. Notice that the properties have the capital P and the functions have the lowercase f with the parentheses. So let's just do dot hide. It's not that important. So we don't have a value assigned to this variable yet. We've declared it, we've given it a type, but we haven't assigned it a variable or a value. Health, we assigned a value. The collision shape, we have not assigned a value. So right now, the value would be null. There's never been a value. There's no value in there right now. So if we run this script right now, because collision shape.hide is in the ready function of this node 3D, when this node 3D runs, it's going to try to access the function hide within collision shape. There is no collision shape. We've never had a collision shape. There's no collision shape assigned here. We have not done it. So we will get a null error. And I'm not sure how this project is set up. Hopefully, if I just run this, it will give me the error. Yes, cool. And not call method hide on a null value. It's a null value because we never assigned anything to it. So if we go back, we do our export tag, have our collision shape. Go to node 3D, assign it to the collision shape, hit OK, and we can run our script and it will be happy. So nothing happens because else is here, but it runs, which is a big roadblock in programming sometimes. Anyways, so that is everything I wanted to show within Godot. So please, like I said earlier, leave a like, comment, subscribe, anything like that. So have a good evening, day, night. Goodbye, guys.